Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the Seagray 2023 Grid of the Future Symposium. And these interviews are with the leaders at Seagray and the leaders of the industry. Hope you enjoy. My next guest is Robert Gardner, Mathew Robert Gardner. Robert Mathew Gardner, right? Yeah. You are the Vice President of Electric Transmission, Dominion Energy.
That's correct. That's right.
We're going to get a lot into that.
Yeah.
First of all, how did you get it? You're a double E from, you're a tech graduate, right?
I am. I went to Virginia Tech.
Oh, I thought you were a Georgia Tech.
Yeah.
Oh, never. Okay.
Right. Even one better, Virginia Tech.
Oh, yeah. All right. I heard that. I went to Georgia Tech.
Oh, okay.
We're both Southern Tech boys.
Yes, that's right.
So, how did you get into it? What made you get into the electrical industry as a whole? Not necessarily your role right now, but get into it.
Right. It's really interesting. So as an electrical engineer, I was graduating in 2003.
Okay.
And I was graduating in December. And for those that are in the industry, they'll remember that 2003 was a seminal year for our industry, because on August 14th of 2003, we had the Great Northeast Blackout.
Oh, yeah. That is a seminal.
Yeah. And that changed our industry as we know it today, in terms of how we have responded, how we have reacted, and how we have reoriented our industry to focus on reliability in such a way that we don't get back into that situation again. Well, that was happening as I was wrapping up my undergraduate degree in electrical engineering. And I hadn't conceived of myself as a power engineer until I saw that opportunity to engage in a part of electrical engineering that could make a difference.
Oh, yeah.
It looked like there was a lot of work that needed to be done. And I'm glad I made the decision to pursue power engineering.
Yeah, because at that time, a lot of people were going into electronics and all of some of the double E's was moving into that area.
Yeah.
And we've had a little bit of a dearth lately, but now it's, again, people want to make a difference. Young people want to make a difference.
That's right. That's right.
You should make a difference in the power industry, because that is a global game changer for everybody.
It absolutely is. And, you know, at the time, the trends in electrical engineering were bio, info, and nano, and those things are all really important.
Yeah.
But energy really wasn't a headline issue at that point. And so I looked at the events that were taking place and saw quite an opportunity space.
So you were very prescient in that.
Yeah.
Tell me about your role at Dominion.
Yeah. So I'm the Vice President of Electric Transmission. I focus on the planning and operations functions within the electric transmission business unit for Dominion Energy Virginia. And in order to do that, we focus on, looking at the grid, modeling the grid, understanding how the grid is changing, understanding how our customers' load is growing, what the drivers of that load growth are, and then planning the infrastructure so that it's there as that load materializes. That's the planning component. But then we also operate the grid, and that involves a real-time operations component. That means operators that are looking at our grid 24/7. Operating it so that the lights stay on 99.995% of the time. That's right. Or at least 4.5-9. But then that also includes those operations and maintenance activities that keep the lights on out in the field as well. Right. So that involves hundreds of technicians, hundreds of line workers, hundreds of electricians, and then the support staff to make sure that we maintain those assets, that we manage those assets. So that's my function at Dominion Energy.
I would ask you what keeps you up at night, but all of that keeps you up at night. Because if you don't plan well and you operate, then you have to fix what you broke by not planning well.
Oh, yeah.
And vice versa. If you're operating it, but you didn't plan well, and there's a lot of change and you can't adapt to it because we all talk about hardening of the grid.
Right.
Now people are talking about the flexibility.
That's right.
Flexibility of the
That's
grid.
right.
Because you harden it, you make a promise. You just mentioned something. I retired as the president of the Electric Power Reliability Alliance. We focus primarily on distribution,
right.
that end of the world.
Right.
And one of the things that in the name was electric power reliability,
right.
and how important it was at the end of the grid edge.
That's right.
Because that's where the changes are being caused, because there's so much change and demand change at the grid edge that from generation through transmission, you're having to make all these adjustments. With that said, as you look at what you're doing, I want to focus on the planning component.
Sure.
How do you plan to decarbonize, decentralize, digitalize, flexibilize, and make it reliable? How do you do that?
Yeah. Well, you mentioned you put it very well. Our industry really is at a crossroads where three roads come together, and we're having to navigate that. And I see that as digitalization, electrification, and decarbonization.
Okay.
Or you can put it another way: electrification, datafication, and greenification of the grid. And it all does start with planning. Okay. So the way we look at it now is we want to plan not just based upon the way we've always done it, but we're trying to integrate data and our ability to not just look at where the models are today, but then also pull in data from all sorts of sources, data from how our grid is operating, advanced data in terms of how we plan the system from a modeling perspective, but then also automating our system as well. So we're trying to really leverage data and data analytics to kind of play the grid of the future. Planning has become a completely different discipline just over the period of, I would say, the last 5 to 10 years.
Okay.
Planning was once on an arc and a rhythm of 15 years, and now it's on an arc and a rhythm of 1 to 5 years. And so that's changed. We no longer plan based upon dozens of models. We now plan based upon thousands of models, and automating all of that, driving those models with data is certainly one of the key things that we're focused on within the planning space.
You must be hiring a lot of data scientists, right?
Well, yes, data science is becoming more and more of kind of a background capability that's needed regardless of whatever technical function you have within the industry. If you go and work for, if you're an electrical engineer and you go work for the auto industry, guess what? You're doing coding. If you're a mechanical engineer and you go work in manufacturing somewhere, guess what? You're coding. And now in the utility space, more and more, if you're coming in as an engineer, whether you're a mechanical engineer, civil engineer, electrical engineer, you're coming in, and to be successful, you're coding. And so certainly there's a strong component of data science in that, in every dimension of our engineering discipline.
Where are the bugaboos? Where are the potential areas that, as I said, keep you up at night when you're looking at it? You got this current operating grid, you got change throughout that grid, and you got the planning stages. But what is it within the operations part of it that keeps you up at night? Is it weather related? Is it cybersecurity, or it's that and everything?
Well, most customers don't think much about their electrical use, right? We're in the background, and that's largely due to the fact that we have been focused on reliability, and we've executed collectively as an industry. We've provided reliable power. For providing that level of reliability takes a lot of work, and you're right. The 21st century is different in terms of the threat landscape. Cyber is a thing, right? The cyber threat space is something we're concerned about. Certainly, also, extreme weather is something that we're also prepared for as well. So yes, the conventional threats to our grid, whether it be weather, and then also the emerging threats that are associated with everything we have to deal with now in the 21st century, are components that we now have to factor in and build in so that we can deliver that reliability that our customers expect. That reliability is being challenged as we start to think about how the grid is changing, and the uses of electricity are changing, and the electrification that I mentioned. So it's definitely, we now have a scenario, where we've changed the paradigm in the industry. It used to be, for all time, that we would predict load and match that load with generation.
Right.
Now we're predicting load, right? What our customers want, what they're desiring. We're predicting that, but then we also have to predict what's happening on the generation side, right? Because so much, a larger and larger sector of our generation is now non-dispatchable. So now we're having to predict both sides of the equation and make it up in the middle. And that's where the wire side of the business comes into play to assure reliability, both on transmission side, distribution, and then the incorporation of storage as well.
This description of the transmission side, the wire side has to balance all of those things.
We're the fulcrum. Yeah.
You are the fulcrum, right?
Yeah.
And it was a step down grid. You'd use these big power plants, hydro, coal, whatever it was,
right?
Nuclear,
yeah.
And you step it down. That's a very stable type operation.
Right.
we're creating instability by all of the Ds, decarbonization. I use the 3 Ds because it can come across, but we're creating instability in the grid, and you have to bring stability to the grid, because not only do they expect, I think, 5.9 reliability, because I think we've delivered that.
Yeah.
They expect it with the world changing.
Right.
And,
right.
and we actually, we move from consumers, from ratepayers to consumers. Now some of them are prosumers.
Prosumers. That's
They
right.
got a car and they got a rooftop and they got the whole thing. That affects everything upline.
Yeah.
Right?
Yeah.
Technology to be able to support that. Mark McVeigh.
Yeah.
He was talking about transients and harmonics
Yeah.
and how he overcame some things with transit.
Yeah.
Well, we never used to have to worry about that before.
That's right.
That's because of DER, all of the loads that are doing this.
Yeah.
Talk about the innovative technologies, how you find them, how do you make it work?
Right. Well, you mentioned a little bit earlier how the top-down paradigm of how our industry works is certainly changing, right? Yeah. We used to generate energy in bulk scale, large quantities, remote places, transmit it over our transmission system, then feed it down into the distribution system. It was a one-way street, top to bottom paradigm. Right. And in that paradigm, the focus of reliability, right? The key to reliability is capacity, right? Building your pipe big enough to get the energy from where it's produced to where it needs to go.
Oh, yeah.
Now, as we change that paradigm, we add grassroots sources of generation, that is behind the meter, DERs, inverter-based renewables. We're changing that paradigm such that it's not just about capacity, how big the pipe is, but capability. And that is how flexible that intermediary system is. So the types of technologies that we're working on to make sure that we can not only get the capacity right, but also bring capability to the grid. It all starts, first of all, with, as I mentioned earlier, data. That means monitoring. It means we need to start monitoring, and we have started monitoring our system with high resolution measurements that, like synchrophasers. We're leveraging digital fault recorders that are providing point on wave data so we can see these higher order harmonics that are intrinsic to inverter-based technologies. So it starts with monitoring, but then you also have to give the grid flexible capabilities. And so that comes down to fax devices, the flexible AC transmission systems, such as StatComs, SVCs. I know there's a lot of acronyms floating around here. We don't have time probably to define them all.
Because when you said fax, I thought you're faxing. I did FACS.
Yes. What is a fax? So certainly it starts with knowing what the system is doing. So you got to get the monitoring right. Then it comes down to getting those flexible solutions. All of that rides on top of a communications layer.
Right.
And so we've had to make some intentional investments in fiber infrastructure so that we can handle the data that's being produced by all of these intelligent edge devices, IEDs. But then the future, as we contemplate resiliency and the emergency restoration activities that take place as we deal with some of these 21st century threats and conventional threats, that opens up the future in terms of things like private LTE and other technologies as well. So you've got to get the measurement right. You've got to get the actual devices right on your grid. Those SVCs, StatComs, synchronous condensers are making a comeback in our industry as well. Then you got to get the communications right as well. All of that is predicated on having the workforce in place that can navigate us to that future, that is native in some of these newer technologies and can help us implement them with the tools and the data we talked about all the way back in the planning section of our discussion.
Okay. It's interesting because I'm gonna close us out with, we have a question about Seagrave, but I want to you mentioned all of that, and it seems like it's about people. If you have the right people in place, all of that, the problematic things about it, whether that's resilience or works better. If you don't have the right people trained and brought up and using the right tools, you're not going to sleep well at night. But if you know you got the right people, you can sleep well at night.
Yeah, we're in the people business. That's the key to navigating, all of the various, concurrent transitions that we're in the middle of right now. You're exactly right.
Last question.
Yeah.
Dominion is very active in Seagrave and IEEE. We're at the Seagrave U.S. National Committee Symposium. Talk about the value of Seagrave to Dominion, to you personally, to the industry.
right? So for Dominion Energy, I'll just talk first of all on Dominion Energy. Seagray gives us that global perspective.
Right.
What we realize is that the solution space is not all in our backyard. It really does leverage a global supply chain, not only a global supply chain of iron in the ground and wire in the air and all of the tools and technologies and equipment it takes to do that. That's certainly a piece of it, but also the global supply chain of solutions, a global supply chain of talent. Seagray gives us access to that. But at the end of the day, Seagray does it in a way that's practical so that engineers can engage. They can get in the working groups so they can make a difference, so they can network with other experts within the industry, but then they can also bring the results of that back home to us so that we know that when we're making some decisions and we're making some significant investments in those technologies, those projects, that equipment, which drives reliability on our system, we know we're making the best decision because we've benchmarked it based upon a global network of professionals within this industry. That's the value of Seagray. One of the things I really love about Seagray is its industry focus, its practical focus in bringing people together to focus on solutions that are going to be implemented. The discussions that are happening within the Seagray space are not discussions about theories that may or may not, come to fruition in 10, 20, 30 years. They're talking about the strategies and tactics, technologies and capabilities we need to build out our grid this year, next year, over this next decade. So it's very practical. And that's where I think Seagray really stands out in terms of its value for the industry. It's practical, and then it provides a strong network of both relationships and contacts.
Excellent. Thank you, Robert, Mathew. It's been wonderful. Appreciate it.
Thank you. I appreciate the opportunity. Thank you.